Hey everyone, Andrew Stormer here, and welcome back to the computer tutorial series where I teach you everything you need to know and tons more of how to spec your own gaming build, your own video editing, YouTube build, whatever you need. So today we're hitting CPUs and we are on PCPartPicker.com, which if you didn't see the last video, link up there, you should go watch it, but that's kind of like the intro to this series, and we are going to get into CPUs today. Your two main manufacturers, AMD and Intel, that's your red team and your blue team. Doesn't matter, there's other brands, but these are the main ones you're going to run into. So that's pretty much all you need to know there. Series, family, nothing, doesn't matter. Sockets, don't pay attention to this right now. This comes into play with motherboards. If your motherboard and CPU socket are not the same, they won't work. But I wouldn't base your CPU you're getting off the motherboard you're getting, so I wouldn't pay attention to socket with your CPU at all. Integrated graphics, we'll hit this in another video. Down here we have cores, speed, and hyper-threading. Now it says simultaneous multi-threading, but I call it hyper-threading because that's what Intel called it, but then AMD started coming out with CPUs that did hyper-threading and they called it something else, so that's why it's called multi-threading, but I'm just going to call it hyper-threading for the sake of things. So these three things are the main three things you need to pay attention to when choosing a CPU. Cores is the amount of processes that can be done at the same time. That means if you have a one-core processor, it's only getting one thing done at a time. But if you have a four-core processor, that means you have four things processing at the same time. And your speed is how many processes your CPU gets done every second. So a 4 gigahertz CPU is definitely gonna get more done than a 2 gigahertz CPU. The higher your speed, the more you're gonna get done, the more cores, the more you're gonna get done. And where hyper-threading comes into play is that hyper-threading turns one core into two cores, essentially. Now, a two-core processor is actually going to be faster than a one-core processor hyper-threaded, but we're not going to go that deep. We're just going to say, for the sake of things, for the sake of simplicity, that hyper-threading turns one core into two cores. So a 4-core hyper-threaded CPU is going to do just about as much as an 8-core not hyper-threaded CPU. Now there's a simple calculation that you are going to use all the time in figuring out the speed of your processors, of all the processors that you're looking at, and is it worth the price. Grab a calculator here, and what you're gonna do is first you're gonna look at how many cores a CPU has. So let's say you have a 4-core CPU. Let's say it's hyper-threaded, so you're going to multiply that by 2, so you have 8. And now you're going to times that by the speed. So let's say you have a 3.5 gigahertz CPU, so that brings you out to a rough CPU ranking of 28. That's all you're going to do. And the higher the number is, the faster your CPU is going to be, the more you're going to get done. If you're making a build solely for gaming, I would say you want at least a 30 ranking, maybe 35, maybe 40. But if you're making a YouTube video editing or a game recording or streaming build, I would recommend somewhere from like 40 to 50 or 60 ranking, just because it takes that much more processing power to process video, to process encoding while gaming. Those are my recommendations for CPU ranking. They actually do make a few CPUs that rank at like 100 or more, but those are crazy expensive and are gonna get super hot, so you're gonna need some super beefy cooler or something. And that brings us into TDP. Now, what does TDP stand for? Thermal Design Power. So roughly what this means is about how hot your CPU is going to be. And don't get a 220 watt CPU. It's going to be way too hot. You're going to need a super huge cooler, and it might not even work because it's running so hot that your computer thinks it's going to burn itself up and it won't even start. So that's why you don't want to do that. You want to be somewhere around 9500. You can go more if you're doing like water cooling or something, but just I wouldn't go super high up. This connects with motherboards, where certain motherboards are rated to take certain amounts of heat. So if you have a 200 watt CPU for heat, and you have a 100 watt TDP motherboard, it's probably gonna overheat, so don't do that. Supports ECC. This has to do with error correcting code RAM, so that's only if you want ECC RAM do you need this in a CPU, and generally you're not going to be using this, so we can ignore that. If we jump over to a random CPU, we'll get a couple other specs here. We have data width, which is 64-bit. This is just the bit depth of what your CPU can process. So a 64-bit processor can process 64-bit Windows, but a 32-bit processor could not process 64-bit Windows. Generally, you don't have to worry about that. Turbo frequency, that's just your recommended overclock max. What's overclocking, you might ask? Well, overclocking is just boosting the speed even more than it came with, and that's gonna increase your heat, but doesn't really matter if you think you can do it. It might wear out your CPU faster, but if you want that little bit more faster processing and CPU ranking, you can do that. Supported memory, 64 gigs. That has to do with your RAM. If your CPU only supports 32 gigs of RAM and you put 64 gigs of RAM in your computer, it's not gonna work. You're only gonna get 32 gigs. So that's something to look out for, but also another one of those things that generally you don't have to worry about it at all. Lithography, this kind of goes hand in hand with TDP. This is the distance between the lanes and how far the information has to travel. And basically, the smaller the lithography, the less heat it's going to put off, just because it doesn't have to send as strong of a signal through to get the information to process. Also, doesn't really matter. Cache. This is the last major thing that you need to understand. There's L1 cache, L2, and L3. So when a CPU is processing something, it has to draw the information from somewhere. And the first place it draws from is the L1 cache, because the L1 cache is the closest to where it processes and is the fastest to draw from. And if you look here, you have an instruction cache and you have a data cache. Your instruction cache is where it stores all the commands for the CPU to do with said data. The data cache is all the information that actually needs to be processed, that needs to have the command done to it. If the data isn't in the L1 cache that needs to be processed, that's called a miss. And then what happens when you have a miss on the information not being there is then it searches the L2 cache. Now this obviously takes a lot more time because it searched and it didn't find it there, so that's time right there. And then it had to go find it in the L2. And if it's there, it takes it and processes it. But if it misses the L2 cache it moves on to the L3 cache. And if you look here, the L1 cache has 664 kilobyte instructions, 632 kilobyte data, and 512 kilobyte L2, and this one almost 16 megabyte L3. So the L3 is a lot bigger than the L1 and L2, and the L2 is bigger than the L1. If you have a bigger L1 cache, that means it's less likely to miss the L1 cache in processing, meaning it's not going to spend a ton of time searching for the information it needs to process going into L2 and L3. But there's a chance that a bigger L1 cache might actually be slower because it has to search through more information. So kind of have a trade-off there. This is just something to understand about CPUs. You don't have to worry about this when choosing a CPU, really. And then obviously you have architecture trade-offs. Intel's architecture is faster than AMD, but is the price difference worth it? The last thing with CPUs, which we'll get to later, is the lanes that every CPU has, which that has to do with the connectivity with the motherboard and the PCI slots and your graphics cards and stuff, which also you don't usually have to worry about, but it's another piece of the puzzle there. So if you didn't understand anything else that I said, what you need to take away is cores, hyperthreading, speed, and the calculation to figure out how fast the processor is that you're looking at. That's everything you need to know and way more about CPUs. So thank you all so much for watching, and I'll see you next time.